Have you ever looked at the moon and wondered, why doesn't it fall back to the ground or go flying out into space? Why does it spin around the Earth? Well, it all has to do with the science of orbital mechanics. To help you understand orbits, let's do a thought experiment called Newton's cannonball. Let's say we are on a planet the size of Earth, but with no atmosphere, and we have a cannon on top of a hill. We can set the speed of the cannonball fired to whatever we please. If we fire the cannon at a low speed, our cannonball will do about what you expect. It will fly horizontally and attempt to fly away from the planet, but gravity will pull it back to the ground. If we fire the cannonball at a specific speed, known as orbital velocity, which is around 28,500 kilometers per hour, our cannonball will be pulled down by gravity, but will also be flying away from the planet, which leaves the ball going in this direction. The cannonball is falling towards Earth, but constantly missing it, leaving it in a state of perpetual freefall. The cannonball is said to have reached orbit. You might think that the cannonball would lose speed, but this is not the case. Since the force of gravity is pulling on the cannonball perpendicular to the cannonball's direction, it doesn't lose any velocity. It should also be noted that the speed you need to travel to reach orbit changes depending on altitude. Now, let's fire a cannonball even faster. Due to the cannonball's higher speed, it will begin to fly away from the planet, slowly gaining altitude. However, since gravity is pulling back on it, it will begin to lose speed until it falls down, where it will begin to gain speed, and then it will begin to go back up again. This is called an elliptical orbit because it traces out the shape of an ellipse. The highest point on the orbit is called the apoapsis, or apogee if the satellite orbits Earth. Similarly, the lowest point is called the periapsis, or perigee if the satellite orbits Earth. Let's say we fire it even faster, at a speed of around 40,300 kilometers per hour. At such high speeds, the force of gravity can no longer hold the cannonball in an orbit, and instead the cannonball goes flying out into space. Now, orbital mechanics is a massively complex science that people spend years studying, and there's no way a 3-minute video could really explain everything, but hopefully you now understand the physics that makes satellites fly, dictates the orbits of planets, and keeps the moon in the sky.